Wow, it gets close to home, or maybe close to the driver's seat. Our next speaker is Alena Skliarova. And get this, she is one of Google's top 10 Android bug hunters of all time. She's here to talk about Pwned on the road. She found a vulnerability that could let attackers manipulate what you see on your car's infotainment screen. She's even going to show a proof of concept. This is super important stuff. Let's give a huge welcome to Alena Skliarova.
Hello. Hello everyone, guys. Thanks for coming. Is it working? Yeah, thanks. So yeah, in this talk I'm going to talk about how I managed to find vulnerabilities in Android Automotive, and as a result, how I was able to alter the content of a visual appearance of car's infotainment system. So we also take a look at something called resource overlays. So I'm going to show you what they are, what they do, what their purpose, and what the key role they play in this attack. Yeah, at the end, I'll share some recommendations, some security tips you can use to avoid similar issues in your products. So this is one of my most easygoing talks, so enjoy. I would like to introduce myself. My name is Alena Skliarova. I'm a security researcher focused on Android operating system. I'm a little bit a reverse engineer as well, and in my free time I enjoy bug hunting. I'm searching for vulnerabilities in Android operating system. And yeah, recently I received Google Most Valuable Hacker rewards on the latest bug squad. So here's a plan for today. As you can see, we had a lot of things to discuss. So first I would like to talk about resource overlays as promised, and I'm going to show you what they are, what they do. Next we're going to walk through what's required to create an overlay and how it can be used to attack other applications. Then I would talk about my research I conducted across different Android platforms, which helped me to identify vulnerable components. In Chapter 4, I introduce the system library called Car-UI-Lib and explain the role it plays in Android Automotive, and I'm going to show you what exactly went wrong here. In Chapter 5, I'll show you how I built an exploit and demonstrate the attack. And finally, I wrap up with the key takeaways and security tips, practical advice you can use to avoid similar issues, similar vulnerabilities in your own products. So let's get started. Android Runtime Resource Relay is a super powerful mechanism in Android. So this mechanism is usually used way more often than you might think. It was initially designed for system developers, for manufacturers, so they can adjust the look of the operating system, right, of the user interface, sorry. So like everything you see on the screen, like fonts, colors, shades, how layouts look like, buttons, everything is the result of resource overlays. So here I found a way how you can use resource overlays not just for customizing user interface, but for attacking user and system applications. So the basic structure of Android application in the context we are currently interested in is the following. So we have Android manifest and we have a resource table which contains resource IDs, right, and resource values. For example, I created a string resource here called grid string, and I assigned a value and I placed it in a text view so it shows up nicely in the center of the screen. So under the hood in the resource table, it shows that the grid string has this value, right? And it's linked to specific resource ID. But what does a resource overlay in the classic setup? So here is our application again, right? In the classic setup, an overlay is a separate application that does not contain any code, but it has an overlay declared in the manifest, and it has the resource table, which has new resource values, right? So new target resource values it wants to overlay. And finally, when overlay is created, when it's enabled, the system creates an IDMAP file, and finally, yeah, it gets mapped to the application process. So yeah, system accesses the IDMAP file, and our resource is linked to the new value behind the scenes. So yeah, as I said, as I already spoiled, if we look into the application process memory, we can find here a new mapping. So a new map section in the memory map related to the IDMAP file. So yeah, even though the resource table was already compiled and the application itself was already compiled, we were able to reassign the value of the string, right? So we managed to override it with a new value, in this case, hello TenguCon. So let's take a look at how overlays work in real life. Let's start with the system overlays. So they live in different partitions of the system, mostly like vendor, partition, product, or system. They usually sit inside overlay folder, but it's not necessary. So all these APKs, they have no code, as I said, but they have overlay declared in the manifest. And they have the list of target resources they want to override. So let's open proc-pid maps, in this case, maps of system server, right? So you can spot here a large number of IDMAP files. Let's zoom in one of them. So yeah, IDMAP file is a special file with its own magic that is created by IDMAP service. So its purpose is to map original resources to the new values, overridden values, right? So IDMAP file can be dumped for easy reading, like this. So for example, here I took Google Web View overlay, which I found in the system server maps. So in the IDMAP file, you can find the target path, which points to framework res APK. It's the framework resources, right? And the overlay path, which leads to Google Web View overlay APK itself. So yeah, the mapping clearly shows that how actually resource overlays work. So we have here XML configuration, and we override this XML configuration with the new value, right? So let's pick inside the overlay APK what's actually, yeah. So as you can see, the manifest declares overlay. It has attributes, has code false, as I said, because there is no code in such packages, and it targets package Android, which means this APK, this overlay APK, wants to override system resources. And if we decompile the overlay, we can find the configuration file. So this file will be used as a replacement, and it has many WebView providers here inside. So let's take a look how to create an overlay, right? And what is necessary to know about the target package. So we already covered the overlay packages. So you declare the overlay in the manifest, right? You specify the target package, and optionally you can set a priority. So the higher the priority, the larger, the later the overlay will be applied. So for example, if we have one target APK and we have 10 overlays, so the overlay with the highest priority will be applied last. Also, overlay APK can declare a resource map. So it's the list of resources that it tends to override. So if it's not specified, the system assumes that the whole package is ready to provide its resources as a replacement. So now about the target package. In general, it doesn't need to declare anything special, but if you want to, you can define an overlayable policy in resources. So this policy specifies which requirements an overlay package must meet. So there are some of them in the official documentation. They're listed on the slide, and except one, they impose certain restrictions on overlay packages. So yeah, except the public policy. So it turns out that the policies impose usually, they impose restrictions on overlay package, but this one does not impose anything. So yeah, like any application can override resources of another application with public over-label policy. So naturally, I wanted to find out why it works like that and why public policy, it looks kind of dangerous. So, and yeah, I found the ID map manager code, and it calculates the fulfillment policies, and we can see that public policy is set by default. So it's set like it's fulfilled by default with no requirements, comparing with other policies, let's say signature policy. So in this case, signature policy requires that target package and overlay package should be signed with the same key, right? Which is kind of hard for an attacker. And also there are product and vendor policies. They require that overlay should sit in one of these system partitions, which actually user regular application would never have an access. So yeah, I concluded that public overlay policy is dangerous because it allows overlaying any resources from any application with no requirements. So I decided to research further, and I asked myself, are there any APKs, let's say installed, right, pre-installed APKs that use public overlay policy? So I put the plan. So I wrote a tool that extracted all the pre-installed APKs from different Android platforms. Then I decompiled them, but automatically, of course, not by myself. And then the tool searched for public overlay policy. And if it found any, all these apps could be considered vulnerable. And here's the list of target platforms. So I gathered APKs from Android phones, tablets, Wear OS, Android desktop, Android TV, Automotive, Honda emulator, and I took some different OS releases, which gave me 1.5 different APKs, pre-installed APKs. So my tool analyzed all of them, and here's the results. So it turned out that the most system apps from Android Automotive were vulnerable. So you can see some of them on the screen right now. So this is the launcher, settings, right? Google Mobile Services, system updater, permission controller, and many, many different system applications. And the most surprising part was that all these apps had the same public overlay policy with the same set of resources. So yeah, this is the common roots of evil. This is public overlay policy, which I found in all these packages. And we have a lot of resources here, right? That were, and you as an attacker had an opportunity to override these resources. So after some research, I found that all these apps, they imported the system library, a static library called Car-UI-Lib. So yeah, let's dig through this system library. So Car-UI library is kind of essential. It's a static library that provides an API for customizing user interface. It lives in this path in AOSP I found here. And thanks to resource overlays, the library allows customizing user interface, as I said, right? So like basically everything, how layouts look like, buttons, toolbars, colors, like shades, focus behaviors, and many, many different things. And what's more important, that every app that imports this library can redefine the resources and build the unique user interface. For example, let's take a focus highlights, right? So this is how user interface elements look like when you navigate through them using rotary controller. So we'll talk about rotary controller a bit later. So Car-UI library controls this behavior, right? And applications can override how focused elements look like. And this was the vulnerable parts of the library. So I opened the library in JADX, and I immediately found that I found here overlayable XML file with the same public overlayable policy, with the same set of resources. So yeah, not all these resources were potentially dangerous. Like most of them were quite useless. I found some of them interesting, especially two drawables here. I highlighted them on the slides. So these two drawables, they allow overlaying the content screen. Let's move on to the chapter number 5, and here I'm going to show you how I developed an exploit and demonstrate the attack. So the idea was the following. I created an Android application that contains an overlay, right? So then I defined the overlay in such a way that it overrides resources declared under the public overlayable policy in vulnerable apps. And then I basically overlay system applications, and I alter the content of cars infotainment system. So yeah, I promised you to explain what is the role of rotary controller or rotary knob. So it really matters here, because the bug could only be exploited, reproduced when the user navigates the car infotainment system through rotary knob, not by touching the screen. And yeah, in Android emulator you can find this feature. You can open Android emulator settings and find car rotary. So it basically emulates the input, so you can find it quite useful here. So yeah, it looks and works like a joystick. So now let's talk about the exploit. In the attacker app, we declare a manifest, right? We declare an overlay. We set the target package, in this case, launcher, just for example. Then we specify a resource map, which looks like this. It's a separate file, overlays.xml. And yeah, here we have two drawables. Then I decided to override them with a new image, say this guy right here. So let's try to overlay launcher up. Here's gonna be a video. Yeah, so as you can see that everything that gets focus in the UI becomes a cat. So yeah, it looks a little bit embarrassing actually, and a little bit funny, but also it's dangerous because we're able to override the contents of the system launcher. It's quite dangerous, right? Maybe this cat looks silly, but if someone uses it like for, let's say, deceive people, they can use another picture, another drawable, right? Not for jokes, but for real attack. So I prepared another video. This time it's not a cat, but it's a realistic fake launcher. And here I crafted the image that looks like a real launcher, but it has another shortcut layout. So yeah, it's harder to notice it visually, but I hope you can do it. I'm sure you spot the difference. So as you can see, right, here and here, here and here. So basically puts another image, yeah, that looks like, it looks like the real launcher. So let's say if the user might be used to know that Play Store being first icon, right? So I created an image that has Play Store, but let's say vulnerable Play Store, and I put it first, and user presses on it, and it opens my application, which requires, which asks for permissions. So yeah, this is how we can deceive people. So let's try overlay settings application. So the idea is the same. So here we can overlay major fragments of settings UI with our cat. So the permission controller was also vulnerable, and this is how it looked originally, and this is what it devolved into. So let's try to overlay companion app. This one is used to pair external devices over Bluetooth. So here I was able to create a scam ad because the cat looked way too ugly in this configuration, because I was able to overlay the top part of the window, not the whole window. So I created this kind of strange image with American Eagles and gambling ads. So let's try to overlay Google Play services. So yeah, here I was a little bit creative. Instead of QR codes that normally should lead to Google account settings, I replaced it with QR code that leads to my GitHub profile. So yeah, basically I replaced the QR codes, and if I were a malicious hacker and a bad person, I would definitely get a lot of stars on my GitHub account here. So here is our final chapter, key takeaways. So yeah, I would never tell you about this story, about these vulnerabilities publicly if Google hadn't fixed it. So yeah, Google fixed it, and they did it properly and pretty fast in a few months. So yeah, they did it exactly the way I recommended. So this library is safe right now. So the main security tip for you is that try to avoid using a public over-label policy. So you may remember this slide, right? So try to use all these over-label policies, but try to avoid using public. So here are key takeaways from this presentation. We found that Android runtime resource relay is quite a powerful mechanism that allows overlaying application resources at runtime. We also found that Car-UI-Lib contained the resource set with unsafe over-label policy. We also found that all applications that imported Car-UI-Lib were vulnerable to the overlay attack, and try to avoid public over-label policy, just in case. So that's it. Thanks for listening, and I'm open to questions. Any questions? Yeah, please.
Did you ever find out why it was set to public? Was it a mistake, or was there a reason that they had it configured that way?
Great question. I think it was a mistake. Yeah, I'm pretty sure it was a mistake. I think that this policy type was created for debugging purposes, not for like production builds. But it's my suggestion. I'm not sure 100%. Thank you. Any questions? No? Oh, thanks. Have a good day.